Good day, learners. Welcome to General Chemistry class. It's good you are back. Are you excited for today's lesson? Before we start the discussion, let us review first your understanding of the last lesson. How can you identify a mixture if it is homogeneous or heterogeneous? Okay, so some of you will answer if we can see more than one phase of matter or different regions in the sample, it is heterogeneous. While in homogeneous, if the composition of the mixture appears uniform no matter where you sample it. Okay, so at the end of the lesson, the students will be able to familiarize with the types of mixtures and its separation techniques and identify different examples of these mixtures. So we have here the mixture. When we say mixture, it is a material made up of two or more than different chemical substances which are not chemically combined. So there are two types of mixtures, the homogeneous and heterogeneous. A homogeneous mixture is a mixture in which the composition is uniform throughout the mixture, while heterogeneous is a mixture in which the composition is not uniform throughout the mixture. So we have here example of homogeneous is solution. Solution is a homogeneous mixture of two or more substances. It may exist in any phase. It is consists of solute and a solvent. And solution can be separated through distillation and evaporation. Okay, so colloid and suspension are heterogeneous. Colloid is a heterogeneous mixture in which the dispersed particles are intermediate in size between those of a solution and a suspension, and it can be separated through filtration. Suspension is a heterogeneous mixture in which some of the particles settle out of the mixture upon standing, and it can be separated through decantation. Okay, so solutions. The major component is called the solvent and the minor components are called solutes. So here in our example, let's say for example, our solvent here is water and our solute is salt. So when we add this or when we mix this together, it will be a solution. And this example is homogeneous mixtures. Again, solution is homogeneous because no boundary is visible in the entire solution. So in a mixture, differences may exist between regions or parts of the whole system. Material exists in three states: solid, liquid, and gas. Okay, so next is suspension. Suspension is a heterogeneous mixture in which the solute particles do not dissolve. Okay, so makikita natin dito sa example natin na sand and water, makikita natin na hindi siya totally nag-mix. Makikita natin yung particles ng sand. And that is an example of heterogeneous mixture. Colloid is also a heterogeneous mixture. Colloid are any substances consisting of particles substantially larger than atoms or ordinary molecules but too small to be visible to the unaided eye. Okay, so milk is an example of colloids. To summarize all the properties of solutions, colloids, and suspension. So solutions is homogeneous. Colloids and suspensions are both heterogeneous. So these are their particle size. And solution do not separate on standing, and it can be separated by means of filtration, and it do not scatter light, while colloids do not separate also on standing, and it can also be separated by filtration. In Tyndall effect, it scattered the light, while suspension, the particles settle out and it can be separated by filtration, and it may either scatter light or be opaque. Let's start discussing the separation techniques. So we have three examples of separation techniques. We have distillation, evaporation, and filtration. Okay, so let's start with distillation. Distillation is the process of separating the components or substance from a liquid mixture by using selective boiling and condensation. So dry distillation is the heating of solid materials to produce gaseous products. So it may condense into liquids or solids. So I will insert a clip so you can see the process of distillation.
Can you separate a mixture of acetone and water? Yes, it can be achieved by distillation. Let us have a look at the procedure of separation using distillation method. Firstly, take the mixture in a distillation flask fitted with a thermometer. Observe carefully how the apparatus is arranged. Then, heat the mixture slowly, keeping a close watch at the thermometer. See the acetone vaporizing and then condensing in the condenser. This acetone can now be collected from the condenser outlet. On the other hand, the water is left behind in the distillation flask. Do you know there are several important applications of distillation? Let us discuss a few important ones.
Okay, so next technique is evaporation. Evaporation is a technique used to separate out homogeneous mixture that contains one or more dissolved salts. The method drives off the liquid components from the solid components. The process typically involves heating the mixture until no more liquid remains. So this is an example of evaporation, yung paggawa ng asin. So in many parts of the world, table salt is obtained from the evaporation of seawater. The heat from the process comes from the sun. So ang ginagamit lang na pang-init sa liquid ay yung sun. So kapag naubos na yung liquid, makukuha na yung mga salt.
In this activity, we shall demonstrate how to separate salt solution by the process of evaporation. We have taken a glass of water and we are going to mix a spoon of salt into that. We'll stir it till the salt fully dissolves. Now we are going to pour this salt solution in this vessel and boil it till it evaporates. Water has evaporated, leaving behind a salt. So in this activity we can see how to separate the salt from the salt solution by the process of evaporation.
Okay, next is filtration. Filtration is a method for separating an insoluble solid from a liquid. When a mixture of sand and water is filtered, the water passes through the filter paper and it becomes the filtrate. Okay, so I will also insert a clip in which you can see the process of filtration by using a filter paper.
The paper is folded in half, then folded in quarters, and the tip of one corner is torn off to allow for a snug fit in the funnel cone. Then we place 100 ml of water in a beaker, and then we add 50 grams of sand.